Welcome back. Let's get this going. We're going to go over the risk matrix and the hierarchy of controls. We're going to do this because it's a very important part of this course and of your career. So first, we're going to take a close look at the risk matrix, since that's the first step in the process. Then we'll look at the hierarchy of controls. Look at both severity and of the outcomes and the likelihood as it would happen, and then you plot those on the matrix. It's pretty simple. That will yield a risk number, risk priority number, whatever you call it, which will risk rank, which will allow us to rank them in order of risk. There are many, many versions of these out there, but this 5x5 one is very useful and covers most instances. Although it gives description of severity for people, property, and environment, not all hazards are going to have all these outcomes. In fact, in the world of safety, most of our outcomes are going to be on people. And there could be some environmental ones, but that's going to be most of the time. So this is a 5x5 risk matrix. Let me move my head up here. And as you can see, it's you've seen it before, but we're going to look at it just a little closer, more detail. You have incident outcomes and health effects on people, property damage, environment, and here, and then likelihood of occurrence, very likely, unlikely, possible, likely, and very likely. We're going to look at each section a little closer. This is the severity levels right here. You have 1, which is the lowest, 2, 3, 4, 5, obviously. First aid or no injury. Property damage is light, environmental is light damage. 2 is injury illness with no lost days. So moderate property damage, moderate environmental impact. Number 3 is injury illness with 1 or more days away from work. Property damage is significant. Environmental impact is moderate, reversible. 4 is permanent partial disability, hospitalization of 3 or more. That's pretty severe. Property damage is severe. Environmental impact is significant, but it's reversible. And 5 is death or permanent disability. Property damage is catastrophic. And environmental impact is significant. That's the severity levels. All right. Again, there are outcomes listed for people, property, and environment. They are there in case a hazard affects any one or more of these, but most hazards will not affect more than one. Again, there you go. Let's a little closer look at it. There's the matrix again, just to give you a base. All right, this is the likelihood. The likelihood section is pretty self-explanatory. Very likely is 1, unlikely is 2, possible is 3, likely is 4, very likely is 5. Now, if you look at all the different risk matrices, you'll see all different kinds of descriptions in there, but they all mean pretty much the same thing. They're going to have a likelihood that's going to be not likely to happen. They might define it differently, or unlikely. Possible, that's kind of the midway. Yeah, it could happen. Likely to happen, or very likely. And this is one that's kind of like in the middle. It's simple, not a lot of verbiage to it. So that's why I like this one. So after the severity level and likelihood have been established and plotted, the result is the risk ranking number, the risk priority number, the risk number, whatever you want to call it. And so the risk level now, or the risk level, they all mean the same thing. So if you have a risk 15 or greater, it's a very high risk. Immediate actions required to reduce severity or likelihood, because if you reduce either one of those, of course, you'll reduce the overall, or you can reduce them both. High risk action should be taken as soon as possible. Moderate risk, evaluate need for risk reduction measures. Action may or may not be needed to reduce to acceptable levels. And 1 to 4, low risk, generally no action required. All right, the risk priority number gives us the risk, the RPN. Again, it's all the same. If the risk is low risk, 1 to 4, most likely nothing further needs to be done. Now, if it's very high, 15 or greater, most likely something must be done immediately. So that's the high and the low of the two. Those two are pretty cut and dry. If you got them, you either got to do nothing, you don't have to do anything, or you got to do something, and you got to do something pretty quick. Now, the other two, well, look, with one of these, the decision-making process, therefore, is pretty simple. Now, if its risk is high, 10 to 14, most likely something must be done, but not immediately, but you still need to get it done. And if it's moderate, 5 to 9, something might be done depending on higher risks, available resources, time, etc. It might just get pushed back some from the other more higher risks. That's going to be a judgment call. Again, there's your risk matrix. Should be pretty familiar with that. Do you have to know off the top of your head what everything is on each one of those? No, but you have to have a pretty good idea. If the number of hazards being looked at is substantial, then they would be ranked from the higher to the lower risk priority number, and starting with the highest would be dressed in that order. So you might do 10 things and you rank them all. Then you say, well, this has got a risk number of 25. We better look at that one first, or 20. And then this one's got a 6. So we'll kind of wait on that one. That's the kind of the idea behind this whole thing. The hierarchy of controls. You're pretty familiar with this, but we're going to get a little more familiar with it. After the hazards are analyzed and the risk priority number obtained, now is the time to look at the hierarchy of controls. The reason why I'm going to cover this a lot, because this is important to you, and you should have a pretty good talking ability about it anytime. Starting with the highest risk priority number, go through the hierarchy of controls to determine what controls are appropriate. Seldom will elimination or substitution be something that can be done for an ongoing system. They're most useful in the early design stage or early stages, or when something's being completely redone. If the hazard is a chemical, then substitution might be feasible, because that's usually what's the easiest thing to substitute for. So there's your hierarchy of controls. You've seen it many times, and guess what? You're going to see it many times more in your career and in this class. So we got elimination, physically remove the hazard. This you should know. You should know what elimination does, physically remove the hazard. Substitution, replace the hazard. Engineering controls, isolate people from the hazard. Administrative controls, change the way people work. PPE, protect the worker with personal protective equipment. You can also see on the left-hand side there, the bar that's kind of the same colors. It's the most effective, the least effective. Pretty simple subject here, not subject, but pretty simple diagram here to understand. Start at the top, elimination, physically remove the hazard. Hard to do for an existing process, best in the design stage, but it should be considered anyhow. Substitution, replace the hazard, frequently involves changing to a less hazardous chemical. Engineering, isolate people from the hazard. Keep the people from being physically able to come into contact with the hazard. This is a very effective control. It's called a passive control, and that workers don't have to do anything. It's just there. In other words, guards are the most common. In other words, when somebody gets to operate that machine, the guards are already there. So the control is there and it's doing its job, but the operator really doesn't have to do anything. So it's called a passive control. Administrative, change the way people work. Make sure people are aware of hazards and what they can do to avoid injury. Training, standard operating procedures, job rotation, warnings, and others. Now, the allure sometimes of using an administrative control to management is it's cheap. You don't have to spend any money. It's not too much money. If it's a guard's going to cost a lot of money, then well, can we do it some other way? Maybe, but probably not. If a guard's needed, you probably need to have a guard. But administrative controls are easy to bypass because people can forget training. They can get in a hurry and not do the things that they're supposed to do in the operating procedures. And if you see in a lot of the CSB videos, you're going to see throughout this course, that happens a lot. People just don't do what they're supposed to do, or there's something right in front of them tells something wrong and they don't act on it and something happens. So when it comes to comparing engineering controls and administrative controls, the best choice is almost always engineering control. There's just no doubt about it. Their engineering controls are difficult to work around, bypass, or tamper with. Administrative controls are usually less expensive to implement, but much easier to ignore or skip. Personal protective equipment, PPE, protect the employee. This is the last line of defense. Only use if all other controls won't work. Since they almost always require action by the employee, they are very easy to use, forget, or simply ignore. In other words, you can just forget to put your earplugs in, or put your hard hat on, or your shoes on, and that's done quite frequently. Safety glasses, hard hat, safety footwear, hearing protection, special gloves, and many others. Now, a lot of times, personal protective equipment, is used, getting back to where I am here, in conjunction with others. There might be other controls in place, and maybe for other hazards too. So you'll have personal protective equipment frequently as a control that's in use at the same time as other controls, but usually for different hazards. So both of these tools, risk matrix and hierarchy controls, give the safety professional guidelines to use from the time hazards are identified until they are eliminated or mitigated. You should be very familiar with them. We're going to analyze some hazards. Now, these things we're going to analyze are pretty simple, just to kind of give you a little bit of exercise and going through them. Here's a scenario. 25 horsepower motor is driving a piece of equipment with 3 each 1-inch wide belts and pulleys. It's in a high employee traffic area and there's no guard on it. Okay, 25 horsepower motor with belts like that is going to be pretty powerful. There's no chance of property damage or environment impact any of these scenarios, so we're just going to ignore those for this exercise. Okay, since a motor this size can easily rip off a person's arm, creating a permanent disability, it rates a severity level 4, permanent partial disability, hospitalization of 3 or more. Oh, that's on the old one. This motor is in an area with high employee traffic, creating a lot of exposure, and there's no guard on it. So this makes the likelihood also a 4. Pretty likely, if it's a high traffic, there's pretty likely somebody's going to try to do something stupid. Believe me, they'll do it. So the severity likelihood, 4 times 4 is 16, which is the risk priority number, and that's a very high risk. There you go. 16 is a very high risk. There's the severity likelihood, and there's your risk number. Okay, we'll look at another hazard. Electrical junction box, usually called a J box. 110 volts. It's not covered. There's no cover on. Wires are coming in, hot wires, exposing electrical hot wires. There are employees and customers in this area. So 110 volts kill a lot of people, but that's mainly because it's so common. In a J box, a person probably wouldn't be able to grab it, just come into contact with it. So the severity would be 3, injury or illness with 1 or more days away from work, possibly. Also, likelihood is also a 3, a possible. So you have severity time 3 times 3 is 9. 9 is a moderate risk. Next hazard. This is an e-stop button's missing, leaving a hole in the panel from where it should be, from the control panel of a large piece of manufacturing equipment. But this equipment has 10 employees working on it. It runs 7 days a week. So there's a lot of exposure there. The e-stop would only be used in an emergency stop. That's the E in e-stop, it's emergency stop. Since it can't be stopped in an emergency, the possibility of harm is high in an emergency. That if there's not an emergency, then it wouldn't even be used. So, but the severity is really high. Chances are, if there's an emergency that happens that you need to stop that machine and you can't, it's probably going to do some pretty damage to somebody. So the severity is 5, death or permanent disability. The likelihood of not being able to shut down the machine and the person being injured because of it is probably unlikely. If there was some data that showed that this e-stop or others on this or similar machines have been used many times, this would change things. E-stops usually don't get used very often. And that's why when something's missing like that, sometimes it goes unnoticed. So if you have some data that shows anything different, you could change this. So the likelihood, though, is probably unlikely that would happen. So we have a severity level that's very high, a likelihood that's unlikely. So that ranks as 10, which is a high risk. So 5 times 2 is 10. 10 is a moderate risk. Moderate risk. One could make an argument either way on either the severity or the likelihood, because this is something that's kind of, it's not cut and dry with the scenario I laid out for you. Okay, the next hazard. There's a small air compressor in a shed behind a plant, and it doesn't have a guard on the belt. The only people that go there are maintenance people to change the filter and otherwise maintain the compressor. So it's a small air compressor, so an injury wouldn't be too serious. It wouldn't rip your arm off or anything like that if you got in contact with it. So the severity is 3, injury or illness with 1 or more days away from work. With only occasional activity in the shed, the likelihood of an injury is pretty small. Likelihood is very unlikely. Hardly anybody goes back there only to do it, and they're trained people. So you have a pretty unlikely event that anything is going to happen. They know the equipment, they work on it. So pretty likely. So you have a severity of 3 and a likelihood of 1. So you have a 3 risk number, risk rating, whatever you want to call it. So you got severity 3 times 1 is 3, a low risk. So here's our 4 scenarios. No guard on a large motor, risk priority number 16, 110 volt J box uncovered, risk priority number 9, missing e-stop, risk priority number 10, no guard on belt, a small air compressor and shed, risk priority number 3. So what are we going to do first? We're going to do number 1, right? Next up, the hierarchy of controls. Now we're going to go to them. And that's it. You've seen it before. We'll see it again. So number one, no guard on large motor. We'll look at it first. We can't eliminate or substituting less hazardous. Is an engineering control possible? Of course. A guard would be the best control. Something like this. Pretty simple, pretty cut and dry in this case. All right, here are the other 4 scenarios again. So what's the next one? Scenario 3, scenario number 3, missing the e-stop. Risk priority number is 10. So we can't eliminate or substitute something less hazardous. Is an engineering control possible? Well, an e-stop is kind of an engineering control built into the machine, so replacing it would be the obvious choice. Here are the 4 scenarios again. Scenario 2 is next, uncovered electrical box, or the J box. We can't eliminate or substitute something less hazardous. Is an engineering control possible? The cover of a J box serves as a guard, so replacing it, the guard would be the obvious choice. So putting a guard on it to belong there anyhow would be the obvious choice. So each of these scenarios was relatively simple. They were just meant as an exercise in the use of these 2 important tools. You should be very familiar with the risk matrix, but you should know the hierarchy of controls completely, at least as shown next. Everything on it you should know. You should know the elimination, physically removes the hazard. Substitution means replace the hazard with something less hazardous, of course. Engineering controls isolate people from the hazard. Administrative controls change the way people work. PPE, protect the worker with personal protective equipment. And they go from the most effective, which is elimination, to the least effective, which is PPE. So picture this scenario one day in your future. This can happen. A new piece of equipment arrives at your facility. Everybody's all excited about it, whatever. The plant manager thinks it's noisy. He says, let's get everybody hearing protection. Well, you don't want to say no. You don't want to say to the plant manager no, but you're crazy. But you might say something like, well, we certainly have a hazard here, but let's go down the hierarchy of controls and see what the best course of action we take. Then you do. You can't eliminate, you can't substitute. Engineering controls possible for noise? Yeah, there are. There's a lot of things you can do for noise. We had a noisy piece of equipment in one of our plants. It was a picker and it spun pretty rapidly, and it was sitting on cement, and you'd stand next to it, and it was very, very noisy. So we took this piece of equipment and did 3 things to it. We took it apart and got it balanced. So we make sure it was no vibration in it, because vibration creates noise, obviously. Right? And then we got some material that you put between the feet of the machine and the hard concrete to cut out the sound. And we put that in that, because a piece of equipment on a concrete floor is generally going to get pretty noisy. But if you put the sound reducing pads under it, and it reduces it a lot. And then we made sure that there was no more vibration in it either. So once we did all 3 of those, you could stand right next to the piece of equipment and carry on a conversation. So a lot of times there are engineering controls for sound. Also, we once had a piece of equipment that was noisy, and it was inside a guard, which is an old piece of equipment. We just had this expanded metal cage around it, kind of. So what we did in some of the cage, we just got some that sound reducing foam. It looks like kind of egg crate type of thing, and put it inside part of that cage, and that reduced noise too. So even something's noisy, hearing protection might not be the best answer. If you can reduce that noise and not have to wear earplugs, that's the best course of action. Similar occurrence will probably come up in your career. It's best that you know that there's a right way to address hazards calmly, intelligently, in some kind of an order, correct order. And that's all for this module. Thank you very much.